Hello everyone, welcome back to another IB Chemistry Standard Higher Level video 2025 specification, and today we're going to be looking at structure 1.3.5, which is that each orbital has a defined energy state for a given electron configuration and chemical environment, and can hold two electrons of opposite spin. Sublevels contain a fixed number of orbitals, regions of space where there is a high probability of finding an electron. So, there are some rules or principles that we need to know about when it comes to drawing out the electron, writing out electron configurations for elements. And the first one is Aufbau's principle. His principle is that electrons fill orbitals in order of increasing energy. So starting from the lowest to highest energy levels. Second rule is Hund's rule. His rule states that when filling degenerate orbitals, or orbitals with the same energy in a sublevel, electrons occupy each orbital singly with parallel spins before any orbital is doubly occupied. So what this would look like, for example, if you're looking at a 3D orbital, is that you will fill out 3D like this. Each arrow represents an electron before you fill it out like this. Finally, we have Pauli's exclusion principle. Exclusion principle, which is that no two electrons in an atom can have the same set of quantum numbers, meaning that each orbital can hold a maximum of 2 electrons with opposite spin. And how we represent that, let me draw that a bit nicer, would be in our little square, our box representing an orbital, we'll have one going up and one going down. Each one of these arrows representing its own electron. Two exceptions to Aufbau's principle would be copper and chromium. So if we look at copper, which is 29 electrons, its electron configuration would look like this. Now, you might be thinking, possibly, why is 4s not filling before 3D? Well, that is because this atom has an increased stability with half or fully filled D subshells rather than empty ones. So if we are to draw this out, typically if you are asked to do electron configurations, you will be asked of these exceptions because they are exceptions. 6, 7, 8. Now what happens is that the second electron from over here is promoted to 3D to give it a full orbital. And we have a similar case with chromium, Z24, where our 4s orbital will also promote its second electron so that you have a half-filled D subshell. Just keep in mind that you always fill from S to P to D to F, with each consecutive energy level from 1, you'll have S plus the next orbital, and that specifically 4s is the first to be filled, but it is also the first to give its electrons to 3D to achieve stability. That is all for today. Hope that was helpful and that it was helpful.